All right, my friends, today we're going to take a look at our last of our different reaction types and how that patterns out. So far in this unit, we have talked about bringing people together in our combination reactions where we had two elements becoming one compound. We talked about tearing people apart where we had one compound splitting apart into multiple pieces. We've also talked about combustion where we use a hydrocarbon and oxygen that explodes to create carbon dioxide and water. And then recently we talked about single displacement, where we have a metal and nonmetal in a compound, and a metal that is by itself comes in and attacks the other metal and pushes it out and replaces it, okay? So these are four of our key types. The last type kind of combines the idea of single displacement and kind of combination put together. So imagine a world where you have two compounds, we'll call them A, B, and C, D. And compound AB, let's say they're in a relationship, okay? We'll go back to our ideas of relationships. And A and B, they're in a relationship, they're together, it's okay. It's not great, but it's okay. But they're both kind of lazy and like, I got nobody else to date, so I might as well just stay with, person B here. And person B is the same way. It's like, I got nobody else to date, so I'll just hang out with person A and we'll be fine together in a pretty boring relationship. And then there's relationship C and D. And relationship C and D is kind of the same. Like they're together, they've been together for a while, but it's not fabulous. And then maybe through some happenstance, maybe through some stroke of luck, maybe couple A and B are at the same dance as couple C and D, or maybe they're at the same restaurant together, or maybe they both have mutual friends, and they realize that A is like, wait a minute, I like D. And C's like, I kind of like B. And through no fault of, B and D or A and B, they're just better compatible if they switch partners or they switch who they're with, okay? And that's what happens in chemistry. Sometimes you have compounds that they're okay, they work together, but they're not super stable or they're not the best compounds. And if you can mix them with something else, you can make a better one or a more stable one or one that just is better for energy or the world likes it better. It's just the natural world likes it better. So when that happens, we can have what's called a double displacement. So we are displacing two things, thus the word double displacement. It looks a lot like single displacement, but the difference is instead of having something alone, we now both start in compounds. Okay, so we have a compound AB and compound CD. And then you mix them together, okay? Almost always done in solutions. So down here again, it's almost always done in solutions where A and B are floating around in the liquid water. And they just switch. So the metal for the first one will switch again with the metal with the other one. So the metals again switch. So just like single displacement. And you end up that CB comes together now and then AD, okay? And then the other thing that always happens is one of these two compounds at the end, one of them will stay in solution and one will become solid, okay? So the benefit or the beauty of this or the reason why it happens, if you look at the reason why behind the chemistry, is the formation of a solid is actually preferred in nature. It reduces energy, it increases stability. It's just the way our natural world works, is things like to be in their solid state. So if they can become solid, it's preferred, okay? Where these were in solution, so by forcing one or getting one to be able to become a solid, that's better, okay? So the example we see here is quite complex looking, but some key things we can look at again for our pattern, all right? So in the pattern, we're gonna look for a metal and then non-metal. It can be a group like a polyatomic ion, or it can be a single like we see the I here, okay? So we have a metal and a non-metal together in a compound. It will be in solution, so we'll see aqueous. Plus, so there will be a plus sign always here, another metal and another non-metal in solution, okay? So here's we have one compound in solution, we have the other compound in solution, and then we're going to make two new compounds. And we notice how the K and the PB just switch places. So the K then ends up with NO3. Here we don't need parentheses anymore, but you could put them in. And the PB ends up with the I, all right? In terms of our reaction. Again, of course, it's balanced as we take a look at this. So we have our KNO3 stays in solution, so this is still going to have that aqueous solution, and then the PBI will end up being our solid, okay? So here's our example. In the next video segment for this lesson, we're going to actually run this reaction and see how it looks, okay? Let's again look at our pattern. So on the reactant side, we should have an ionic compound added to another ionic compound, which we see, you know, metal, non-metal, metal, non-metal, okay? So that's how you kind of figure it out, is that you have two ionic compounds. It's the only time we have two compounds to start our reaction. Never will we ever have that besides that. We can have a compound in a single, but not two ionic compounds, okay? And then the products, well, the metals trade partners to form two new ionic compounds, okay? One stays a solution and one becomes a solid. So this is kind of an important thing, that one becomes a solid. So I'd probably highlight, circle this, bold this, whatever you need to do. But one of them becoming a solid is a key part of this reaction, okay, as we do these. And that's our last reaction type, okay, in terms of what we have of our things. Now, when we get to lab, we're going to do some stuff with copper nitrate and some sodium hydroxide. But for our demonstration in a little bit, we're going to do this, all right? We do have one more slide to cover in this, and that's going to be identifying our reaction types, okay? Now, I'm not going to do this for you. This is going to be part of the quiz part that follows up with our reaction. But this is the matching. There's one of each. So now that we have seen all 5 reaction types, you should be able to match these types to their name, okay? So here we have barium chloride with sodium sulfate reacting. Here we have magnesium metal with sodium chloride reacting. Here we have zinc with nitrogen reacting. Here we have methane reacting with oxygen. And here we have just potassium carbonate by itself reacting, okay? So each one of these matches one of these. So there's not 2, there's not 3 of anything, it's 1 and 1 and 1. So there's one of each for those, and then we'll match them, okay? So your next step is to go to the quiz for this. Hopefully you filled out your notes. There'll be several questions, one of which will be this matching one for you to work through. And then when you're done with that, you will go on to the next page in your quiz, which will be about another short video lesson, a little short video of the demonstration, and then questions that follow that. Thank you.